Okay, today we're going to continue looking at section 4.5, which was once again looking at the graphs for both the sine and the cosine function. And to get started on this video, I just want to maybe graph two more sine functions. And what I need you to keep in your heads or on your trig sheet is some basic information about the sine curve. The sine curve wants to start on the center line, and then we draw a hill, and then we have a valley. A sine maxes out at 1 and bottoms out at -1. And normally it takes 360 degrees or 2 pi radians to make a complete cycle. All right, and again with a sine curve, we normally think of a hill and a valley as being a complete cycle. Okay? So with that in mind, let's draw a couple more when we have some transformations attached. So I'm going to start off with some transformations like the following. If I were to have a function that reads y is equal to 1 plus 3 sine of 2 times x minus pi over 6. Could you guys help me graph that function? All right, we have our standard form that I gave you in the previous video. So this is the A, this is B, this is C, and this is D. At some point when you get started on your homework, you're going to have to recognize that not every equation has every part. So as an example, if one of the equations doesn't have a B value, the amplitude is automatically 1. If an equation doesn't have an A value, there's no center line adjustment, so you just leave it where it is on the x-axis. Okay, so not all of these always appear in every single equation. All right, so here's kind of a basic graph, and we start with the center line, which is located at 1. So at 1, we use a broken line. The idea, again, is that the hills and the valleys will be the same size above and below. The B value is called the amplitude, and amplitude is the height of the hills, so we have to go up 1, 2, 3, which puts us at 4. So the height of the hills will reach 4. And then it also gives us how high the valleys are or how low the valleys are. So that's 1, 2, 3. So that will be at -2. So our hilltops at 4, our valleys at -2. Next, we skip the C and we go directly to the D value. And anything in parentheses is left or right, opposite of the sign. And since we have a minus inside, we go right pi over 6. And because we're talking about a sine curve, the sine starts on the center line. The sine starts on the center line. Okay? And because it's a sine, we'll begin with the hill that reaches up to 4, and then a valley which goes down to -2 and gets all the way back to the center line. And to receive full credit, you're going to need to tell me that angle where it finishes its complete cycle. And that's where the C value comes in. So the formula that everybody has on their trig sheet is that C is equal to, when we're in radians, 2 pi over the period. And so we replace C with what it's equal to. C is equal to 2. Think of that as a fraction. And then cross multiply. So when we cross multiply and divide, the period value then is going to be pi. So from where we start our cycle to where we finish with the hill and the valley, so from where we start to where we finish, we have to travel pi to the right. But where did we start this son of a gun? We started at pi over 6. So if we start at pi over 6 and we have to travel pi to the right, then that means we end up at 7 pi over 6. Doing a little common denominator action there. We'd end up at 7 pi over 6. Okay? And again, I'm going to be correcting 6 things. Where's the center line? What's the value for the high point of the hills? What's the value for the low point of the valleys? What's our starting angle? What's our final angle? And then the correct orientation of the curve. Again, for sine, it's a hill first, then a valley. Okay? Feel free to pause the video anytime you need to, right? And I'm going to finish with one more sine curve. And we have one last thing that we need to take care of that we haven't seen yet in an example, and that is, how do we turn one of these upside down? Just like we could turn an absolute value curve upside down, how can we do the same thing with our trig functions? So let me give you an example. So here's a curve where we're going to turn it upside down. So if we have 2 minus 4 times the sine of x, oops, sorry, there you go, of x plus pi over 4. All right, so again, I'm going to be asking to help me graph this. So here we go. Okay, we have an A, we have a B, we have a D, but we don't have a C value this time. So the question really is, what could I multiply that by without changing its original equation? And that would be a 1. So even though we don't always write it in, the C value in this case would be a 1. So we start in the same place. We start with the center line being at 2, so that's easy peasy. So we make a broken line at 2. The amplitude is 4, so we have to go up 4, 2, 3, 4, which would put us at 6 for the hills, and down 4, 1, 2, 3, 4, which puts us at -2 for the valleys. Our phase shift, our D value is pi over 4, but anything in parentheses is left or right opposite of the sign, so the opposite of plus is minus. So this is going to start at negative pi over 4. And I'm going to move that -2 out of the way so they're not right on top of each other. So I'll just put it on the other side there so they're not confusing. There we go. Okay. Now normally a sine curve starts on the center line and begins with a hill and then a valley. But what causes this one to be different? What's going to cause this one to be upside down? The answer is the negative that's in front of the amplitude. So the negative in front of the amplitude causes this sine curve to be upside down. So just like we had with every other curve function we've ever talked about, when we multiply by a negative, it turns the curve upside down. So instead of a hill first, valley second, it just gets reversed, it goes upside down. So here we're going to have the valley first, and then the hill second. So a negative amplitude turns the curve upside down. Okay? We still need to know where this final angle is, so we still have to use the C value. So again, C is equal to, and since the phase shift is in radians, we have to use our formula that's in radians, and this time we get to replace C with 1. So when C is equal to 1 and you cross multiply, the period value is then going to be 2 pi. So from where we start, I'm going to choose a different color so you can kind of see it. So from where we start to where we finish, we have to travel 2 pi to the right. Where did we start this whole thing off at? We started at negative pi over 4. So when we start at negative pi over 4 and we add 2 pi, we end up at 7 pi over 4. And maybe for the last time here, so you can see the center line, the high point, the low point, the initial angle, the final angle, and the correct orientation of the curve. This time, an upside down sine, an upside down sine. Okay? Alrighty. Again, feel free to pause the video if you need to look at anything a little bit closer as I was working through it there. Okay? Now, we need to make a switch because everything we've done so far has been in terms of sines. Now we need to be able to also do the same thing with cosines. All right, what's the basic picture look like? All right, hills, valleys, periods, everything. Now, if we had more time, if I was in person, maybe we would go through the XY table thing that we did yesterday to get the basic picture for a cosine curve. And feel free to do that if you want to. But what you'll find is that the cosine curve starts when the initial angle is 0. The cosine starts at 1, and then as you go through 90 degrees, 180 degrees, 270 degrees, and 360 degrees, what's going to happen to the cosine curve is it starts by going down, it bottoms out, and then it works itself back up to a high point. So what's going to be true about a cosine curve is it normally starts at a high point, goes to its low point, and then finishes coming back to its high. So we normally call the complete cycle for a cosine a high to a high point. From one high point to the other high point is what we traditionally call a complete period or cycle. Okay? What I would ask you to observe though is that the high point will occur at +1, the low point will occur at -1, and just like the sine curve, it takes 360 degrees to get all of that done. A complete cycle takes 360 degrees, or if we were in radians, 2 pi to make a complete cycle. Everything else though, the center line, the amplitude, the period value, and the phase shift, all of those things stay the same. The only thing that's going to change now is what the basic shape of our curve is going to look like. So with that in mind, let's go ahead and graph our first cosine curve. So if I were to give you something as an example like 2 plus 2 cosine of 4 times x minus 30 degrees, could you help me draw that? All right, so let's give it a try. So I'm going to give you an xy coordinate system to start with. All right, and once again, we're going to have an A, center line, B, amplitude, C, period value, and D, phase shift. We always start with the center line, so the center line's at 2, so we go up 2, and we use a broken line to help us draw a decent picture. Okay, our amplitude is 2. That means we have to go up 2 to get to the top of the hills, and down 2 to get to the bottom of the valleys. So up 2 is at 4, down 2 is at 0. Okay, next we skip C and we go directly to D. And since D is in parentheses, anything in parentheses is left or right opposite of the sign. So our cosine curve is going to start at +30. But this because it's a cosine, let me highlight it. Because it's a cosine curve, cosines do not start on the center line. They're going to start at a high point. So above 30 degrees, we have to go all the way up to a high point. And then we're going to ask you to put in a complete cycle. So we're going to ask you to put in a valley and get all the way back up to a hilltop. So we're going to go from a high to another high. And to get full credit, you're going to have to tell me where it completes that full cycle. Okay? Remembering that, of course, this continues on forever to the left, and it continues on forever to the right. It just keeps oscillating back and forth, up and down and up and down and up and down, forever and ever. Okay? How do we get to know what that final angle is? We use the C value. So we take our formula, C is equal to 360 degrees divided by the period, and we replace C with 4. And when I put in 4 and cross multiply, we'll find that the period value is 90 degrees. So from our starting point to where we finish a complete cycle, it takes 90 degrees. Where did we start? We started at 30 degrees. So if I started at 30 degrees and I travel 90 degrees to the right, I then finish my cycle at 120 degrees. And what you'll see on my picture is the value for the center line, the high point for the hills, the low point for the valleys, our initial angle, our final angle, and for the first time, the correct orientation of a cosine curve is start at a high, end at a high. Okay, so again, same 6 things that we're essentially checking with our sine curves. Okay, Now I'm just going to give you a couple more examples. So when you think you have the hang of it, then feel free to just shut this off and go to work. But I'll do a couple more. Here's the next one. Y is equal to -3 plus 2 cosine of 1/4 times x minus 25 degrees. Okay, so here comes our picture. Again, we have an A, a B, a C, and a D value. Again, not every problem in your assignment will have all of those. Some of them, something is missing. That's fine. Just don't worry about it then. But here our A value is -3, so we go down 1, 2, 3. And so our center line is going to be at -3. Next, our amplitude is 2, so I have to go up 2 to get to high points for hills or highs, and I have to go down 2 to get to the low points or the valleys. So up to -1, down to -5. The idea, if you're kind of missing it, is that this height to a hill or this depth to a valley has to be 2, the amplitude. Okay? Next, we skip C and go to the phase shift. And again, anything in parentheses is left or right opposite of the sign. So this is going to be right 25. And because it's a cosine curve instead of a sine, this is a cosine. Cosines want to start at the high point, not on the center line, at a high point. And then what I want you to do is, the best you can, sketch in from that high, go all the way to a low. Gosh, I wish I could draw better. And then all the way back up to a high point, recognizing it just continues on forever in both directions. And then to get full credit, I need to know where it finishes that complete cycle. And that, once again, uses the C value. And the C value is equal to, when we're in degrees, 360 divided by the period value. So I'll replace C with 1/4. And when you cross multiply, we then get, I think I'm doing that okay in my head, we get 1,440 degrees. So from where we start to where we end that complete cycle, we have to add or move 1,440 degrees to the right. Well, where did we start this son of a gun? We started at 25. So if I start at 25 and have to move 1,440, I then end up at 1,465 degrees. Okay? And I think the last one I'm going to do is going to be one where we turn the cosine upside down. So let's do one more. One more cosine example. And let's turn this upside down. And a curve is going to get turned upside down again when its amplitude is negative. So just kind of keep that in mind. And let's do something a little bit extra on this one just so you see an example of it. Let's maybe go, oh gosh darn, how about 3 minus 2 cosine. Now, one last thing before I give you the rest of the equation. There's going to be several examples, there's going to be several examples where they take the C value, and you'll see why when you go to your calculators and try to enter one of these on your calculator. What they do is they take the C value and they distribute inside the parentheses. They distribute inside the parentheses. So as an example, maybe I take a value like 1/2 and distribute inside the parentheses. So what if I had something like 1/2 x minus, oh gosh darn, I don't know, what do you want me to have there? Oh, for crying out loud, how about pi over 6? Okay? What they're doing essentially is disguising the C value by distributing it inside, And so what you will have to do when you see that, and how are you going to know, by the way? How are you going to know? Well, the key is to notice that the x is not by itself. Please notice that the x is not by itself. There's a 1/2 attached to it. So what we're going to have to do to get it into standard form is take whatever that number is attached to the x and factor it out. So in this case, we'd have to factor a 1/2 out of both of those terms. Okay, makes sense. Makes sense. And when you do the division there, pi over 6 divide out a 1/2 would then be pi over 3. Okay? So if you see that, it doesn't look like there's a c value, but there's a number attached directly to the x, we then have to factor that out. So we have to do the distributive property in reverse. Then we're all set to go. We have an a, we have a b, we have a c, and we have a d value. So we're all set to go then. With one little extra thing again this is a cosine curve that's going to get turned upside down. We still start with the center line. The center line is still at 3, so 1, 2, 3. The amplitude is still 2, so we go up 2 and down 2 to get to highs and lows. So up 2 from 3 is 5, and down 2 from 3 is 1. So the highs are at 5, the lows are at 1s. Our phase shift, again, left or right opposite of the sign. So this is going to be right pi over 3. Okay? Again, we don't worry about the period value. And if this was a normal, regular cosine curve, this cosine would then start at the high point. And from the high point, we would go to a low. And then we'd get all the way back up to a high point. But this one is getting turned upside down. And I need you to notice right here, we know it's upside down because the amplitude is negative. So negative amplitude means upside down. So what does upside down mean here? Well, instead of starting at a high, that tells us that we're going to start at a low. And therefore, a complete curve is going to be going from that low up to a high point, and then all the way back down to a low. All right, so that's a upside down cosine curve. So here what we're doing is we're going from a low point to the next low point. And to get full credit, you need to tell me where that angle is, what that angle is, where we finish that complete cycle. Again, using the c value. So here our c value is going to be equal to 2 pi divided by p. We're in terms of radians because the phase shift was in radians. And so we replace c with what it's equal to, 1/2. And once again, I hope you're getting better at this cross multiply. So the period is 4 pi. So from where we start, which is about right there, to where we finish, which is about right there, we have to move 4 pi radians to the right. Well, where the heck do we start this thing out? We start this thing out at pi over 3. So we start at pi over 3, we move 4 pi radians to the right, so that means we would then end up at 13 pi over 3 radians. Okay, and we have everything we need. Center line, the high value, the low value, the starting angle, the final angle, and because of the negative, an upside down cosine curve. Okay? So please give these a try. I should say. Try these on your own. I'll be back on Monday, and we're going to continue to work on these on Monday. So please don't just blow it off because I'm going to keep doing these on Monday. Take some time and try some on your own. Okay? All right, so we'll see you on Monday. Hope everything is going okay.